All right, this is the second part of our review, and we're picking up with question number 17. FISH is a parallelogram. The measure of angle FIS, this angle here, is 50 degrees. If the measure of angle IFS, so let's highlight that one, IFS, this angle here, is 60, find the measure of ISF. Okay, well, we have two angles in a triangle, so I can just add those together and then subtract from 180. So let's see, that's 110. That means this guy has got to be 70 because 180 minus 110 is 70. Question 18a, A and BE is a parallelogram. We know that the measure of angle M and the measure of angle E are congruent. If the measure of angle AMB, okay, let me highlight that. This angle here is 2x plus 20, and the measure of angle MAE, this angle here is x minus 5. All right, so we know that these are consecutive angles, and those are supplementary. So 2x plus 20 plus x minus 5 are going to add to 180. Let's go ahead and combine like terms. I have 2 x's and 1 more x make 3x. And if I have 20 minus 5, that's a total of 15 on the left. I'm going to subtract 15 on both sides. That'll give me 3x is equal to 165. And when I divide both sides by 3, x is 55. So the measure of AMB, which is this guy right here, I would substitute in for my x, 55. So 2 times 55, that's 110 plus 20, make 130. Question 19, JYE. All right, so let's highlight that. J to Y to E. And we're also looking at M to Y to R. These are vertical angles. If the measure of JYE is 110, so MYR is also 110 because we know vertical angles are congruent. 20A, Rich is a rectangle. The measure of HCI, this guy right here, is 10x minus 50. Well, in a rectangle, all of the angles are right angles. So we can set this equal to 90 and solve. If I subtract 50 from both sides, that'll give me 40 on the right, and divide both sides by 10. X is equal to 4. Okay, so let me just make sure I did that right. Oh man, I did that wrong. Let me come back, clean this up. I need to add 50 to both sides. 10x is 140. Okay, so sorry about that, guys. X is equal to 14. At least I caught my mistake. All right, question number 20b. If the measure of HCR, okay, gotta clean this up again. HC to R, that is this angle right here, is 6x minus 20. And RCI, so from R to C to I, this guy right here, this angle is 4x minus 30, solve for x. Okay, well, we know in a quadrilateral that the angles, or in a rectangle, the angles are right angles. So I just need to add these two together and equal to 90. All right, let's combine our like terms. So I have 6 x's and 4 more x's. That makes 10x. A minus 20 and a minus 30 make minus 50. Let's add 50 to both sides. 10x is equal to 140. And if I divide both sides by 10, hey, we're getting the same answer as before. X is 14. Number 20, if RH, okay, let me clean this up. RH is 6, so this guy is 6. CR is 13, so C to R, this is 13. Find IR. Okay, so IR is congruent. IR is congruent to this guy, right? And so I can just think of this as Pythagorean theorem, and then solve for x. So I'll use some Pythagorean theorem. So x squared plus 6 squared is equal to 13 squared. And let's see, what is 13 squared? I should know this. 169, yeah. All right, I'm going to subtract 36 from both sides, and I'll get x squared is equal to 133. And when I take the square root, x is approximately 11.5. You could also just leave at the square root of 133. Question 21, AENGL is a rhombus if the measure of angle EML, so that's this angle here, is equal to 7y plus 27, find y. All right, well, we know that the diagonals in a rhombus intersect perpendicular, so this has got to be a right angle, a 90 degree. Let's go ahead and solve for y by subtracting 27. 90 minus 27 is 63, and when we divide both sides by 7, y is equal to 9. If the measure of ELM, let's take a look at that one. E to L to M, this angle down here is 2x minus 6, and ENM, this angle here, is x plus 7. Find the measure of x. Okay, these angles are congruent, so I can set each of these expressions equal to each other and we'll solve. I'm going to subtract x on both sides and add 6. 2x minus 1x is just x, and 6 and 7 add to 13. In question 22, the coordinates of the vertices of a quadrilateral math are 1, 1. So I'm going to go ahead and just start plotting those. And you know what I'm going to do is I'm just going to highlight, this is the y-axis and the x-axis. So if I want to plot 1, 1, and you start at the origin, 1 over, 1 up. And that's going to be M. I'm just going to label it M. Okay, 5, 3. 1, 2, 3, 4, 5. 1, 2, 3 is going to be right here, and that's going to be A. T is 7, 7. And this is T. And H is 3, 5. So my figure looks like this. There it is. Determine whether the quadrilateral is a parallelogram, a rectangle, a rhombus, a square, a trapezoid, or a kite. Okay, so what we have to do is, well, we need to find the lengths of the sides, because if they're congruent, it could be a rhombus or a square. I'm thinking it's not a square just because doesn't look like one, and the angles don't look like right angles, so it couldn't be a rectangle. But in order to determine that, we need to do some math. So let's go ahead and find the distance of each. Let's find the lengths of each of these sides. So this problem is going to take a little bit. We need to find the distance from M to A. All right, so what we could do, if we're finding this from A to M, look, this is just a little right triangle. 1, 2, 3, 4. We have 4 here, and we have 2 here. So from A to M, that would be the diagonal, would be 4 squared plus 2 squared is equal to, let's just call that x. The diagonal is x. So that would be 16 plus 4 is equal to x squared, or 20 is equal to x squared, and x would be the square root of 20. All right, so now let's do the same thing with t. So I'm going to pick a different color. So if I want to find the length of the diagonal from A to T, and I'm going to call this guy x right here. Let's see, the base of this triangle is 2, and 1, 2, 3, 4. All right, so I'm going to have the same length. So from A to T is also, I'm going to do this in the same color, square root of 20. That's because the sides are the same length as the triangle from M to A. Okay, let's keep going around this. I'm going to find the length of h to t, and so we can see that this is 2, and this is 1, 2, 3, 4. And so from h to t, that is also square root of 20. And the last one from M to A, this triangle here, and that's 2, and that's 1, 2, 3, 4. Okay, so we know that this figure has 4 congruent sides. So this is M to H, and that is also square root of 20. All right, so we have 4 congruent sides. All right, so the next thing we want to look at is the slopes, because if we have perpendicular slopes, right angles, they're going to have opposite reciprocal slopes. So let's find the slope of each of these guys. So the slope, and let me go ahead and kind of just clean this up a little bit, because we got a lot going on here now. All right, so the slope of this guy from M to A is going to be rise over run, so it's going to be up 2 over 4. So we know that this slope is up 2 over 4. All right, and now let's find the slope of the next piece, this guy right here. And this slope is going to be up 4 over 2, or just 2. Okay, so we already know that these are not perpendicular, because in order for them to be perpendicular, they have to be opposite reciprocals. So these are not right angles. So let's see, no right angles. All right, so let's see, I can rule out a rectangle, we can rule out a square. All right, so let's see what else we got. Find the slope of this is up 2 over 4, which is 1/2. Okay, what we do know now is that the opposite slopes are parallel. And then I'll just go ahead and the slope of this piece here is up 4 over 2. Okay, so, and that's 2. So we have opposite sides are parallel. Okay, not a trapezoid. Let's see what else. We need to check the diagonals. All right, so next thing we need to do is, do the diagonals bisect, or do they intersect at a right angle? Okay, we got a lot of things to check here. I'm going to kind of clean this up. So if I draw in a diagonal, I'll draw this in yellow, see if we can see that. This guy here, what is the slope of this line right here? So from this corner to this corner, we're going to be rising 1, 2, 3, 4, 5, 6, and we're running 1, 2, 3, 4, 5, 6. So the slope of this diagonal is 6 over 6, or 1. All right, let's find the slope of the other diagonal. This guy right here. All right, so from this vertex to this vertex, it's down 1, 2 over 2. So this is down 2 over 2, which is negative, down 2 over 2, which is negative 1. So we can see that the diagonals intersect perpendicular. So now, hopefully we can all agree that these diagonals are not congruent. One is just this little short guy right here, and then we have a longer guy. And so we know that the diagonals are not congruent. So which of these could it possibly be? That would be a rhombus. A parallelogram, the diagonals would be congruent. In a kite, the diagonals would not be congruent. But a kite doesn't have 4 congruent sides, so that's why we could rule out a kite. So a lot of work, for one little answer, but that's okay. It was worth it. All right, 23. ABCD is a kite. Find the measure of angle C. Okay, so what we do know is that the diagonals are going to intersect perpendicular, and this vertical and horizontal are going to bisect these angles. So this angle right here, well, what's half of 65? 65 divided by 2 is, how about 32.5? So this angle here is 32.5. We have a right angle. I just need to find the this last angle. So let's add these up. So let's see, 90 plus 32.5 is going to be 9 to 11, 12, 122.5. If I subtract that from 180, that's going to give me 57.5. That's, okay, so that is this piece right here. We're not done. So now we got to tackle, because we want the whole angle C. All right, so now if we look at the triangle on the bottom, let's take half of 55. And 55 divided by 2, 27.5. Okay, we'll do the same thing, 90 plus 27.5. And we subtract that from 180. That gives us 62.5. All right, so this angle here is 62.5. The angle previously we found was 57.5. We need to add these two up to get the whole angle C, and that would add to 120. Question 24, DORK is an isosceles trapezoid. Okay, isosceles trapezoid means base angles are congruent. If the measure of angle DOR, so D to O to R, this angle here is 4x plus 20, and the measure of angle ODK is 6x minus 30, so this angle here is 6x minus 30. And this guy's 4x plus 20. Find x. All right, so we know that consecutive angles are supplementary. So we just need to add these up and equal them to 180. All right, if I have 4 x's and 6 more x's, that's 10x. 20 minus 30 is minus 10. Let's see, let's add 10 to both sides. So I have 10x is equal to 190, and we divide by 10, x is equal to 19. In 25, circle all the quadrilateral that have congruent diagonals. Rectangle, yes. A square, yes. An isosceles trapezoid, yes. In 26, fill in all the empty spaces. Assume polygons are regular. Use the formulas from the notes. Okay, so a figure with 9 sides, that's a nonagon. And let's see, a heptagon has 7 sides. Of course, 4 sides is a quadrilateral. Triangles have 3 sides. The sum of the interior angles is 180. The measure of one angle is 60. The sum of the exterior angles, these are all 360. The measure of one exterior angle, that's going to be 120. A nonagon. Okay, so let's see. We have some formulas. I'm going to go ahead and find those formulas and let's write them down. Sum of the interior angles, this formula is 180 n minus 2. The measure of one angle is 180 n minus 2 divided by n. We already know all of those. And we just have to find the measure of one exterior angle. So use these formulas, fill in the chart. I'm going to go ahead and, just for time's sake, give you the answers. So this is going to be 1260, 140, and 40. We know that these guys are supplementary. Okay, so let's see, 540. This guy is, we would set 180 n minus 2 equal to 540 and solve for n. If we did that, we'd see that this is a pentagon, 5-sided. One angle, if we divide by 5, we're going to get 108, and the supplement of 108 is 72. A heptagon has 7 sides. The sum of the interior angles is 900. Divide that by 7, we get 128.6, and the supplement of that is 51.4. And the last one, quadrilateral, we know that the angles interior add to 360. Each angle is 90, and the supplement is 90. Last question, write in a complete sentence, what is the difference between a parallelogram and a rhombus? Okay, so I'm going to go ahead and erase this guy right here. Here's what we need to write. A rhombus has 4 equal sides and diagonals that are perpendicular and congruent. A rhombus has all the properties of a parallelogram. But the parallelogram does not have all the properties of a rhombus.